Okay, I want to make a quick video on making some soft job links for our current vise. Just a kind of a great intro on Fusion 360 and parametric modeling, how powerful it is. So for instance, here we have a solid model for the hard draw that came with our Curt 6-inch vise. This soft job link that we're going to make is the initial dimensions will be a 1x2x6, but the great thing is with parametric modeling, you can change those parameters and get any desired solid model outcome without having to redesign the whole thing. So for instance, this being a 6-inch vise, Curt makes an 8-inch vise, 4-inch vise. You would just have to update all your parameters as well as the hole locations, and you'd be good to go. So for reference, this is going to be the length. This will be the height. We'll call this depth or thickness, and we'll also need some info on the hole location. So if we get the distance between them, it is 3.875. And we'll get this counterbore diameter, which is going to be 0.781. And we'll do the through hole diameter, which is 0.531. And then we'll get this thickness. We'll use that just in case you want to use the screws that came with the vise, or you can update this parameter if you want different length screws or you got a thicker soft jaw. And then we also need the distance here between the bottom, and that's 0.55. And notice that that is different than this dimension here. So there is essentially a top and a bottom, and I'll give you a little note on that here in a second. So let's create a new file. First thing we'll do is go create our parameters. So we need length, and we'll start with 6. Height is 2. We'll call it depth is 1. Now we're going to make this obviously from 1x2 stock, so we're going to want to essentially mill finished edges on that. So we will need a stock offset. So let's just say it's 10 thou. And we need our counterbore diameter, which was 0.781. Our through hole diameter was 0.531. And then we'll call it our through thickness was 0.19. That gives us the info on the counterbore holes, and now we just need our hole locations. So we'll call it hole offset X 375, and then hole offset Y was that 0.55 plus the counterbore diameter divided by 2, or its radius. And that should be what we need to start our sketch. So in good design style, I guess, we'll create a new component, and we'll just call this a Curt soft jaw blank. The reason we don't specify 6-inch, 8-inch is because, again, that's done through the model parameters. If you wanted this file to be like your soft jaw blanks, for instance, our orange vices have dovetails, so it's just kind of a different design, but the same kind of idea could work there as well. So we'll create our sketch, and all we really need is 3 points. So this will be the corner of our soft jaw. This is hole number 1, hole number 2. You could technically mirror these things. I think it's just faster and easier to just do it in the sketch. And then what we want to do is dimension them. So this length is going to be the length divided by 2 minus the stock offset. So that'll give us 10 thou. Now for the height, since we're not doing half of it, we want height minus stock offset times 2. Again, that'll give you the 10 thou on each side. So we want a rectangle, and let's see. Let's just go ahead and do this. This dimension is going to be this times 2, and the height will be this dimension. Okay, and then we're going to dimension our hole locations to be hole offset x divided by 2, hole offset y, and then we'll do a horizontal constraint here, and this dimension will just equal this dimension. And that's our sketch. Now, since I want to use these points for the hole command later, we're going to end up pulling in a negative direction. So we're going to do negative depth, and then we want to do plus stock offset times 2. And let's just verify these. So if it's a 1-inch stock, we've got 20 thou, 10 thou on each side. The length would be overall length minus a stock offset times 2, and then stock offset, so we're good to go. Now for the holes, we want to just show the sketch again, hit H for the hole command, pick our 2 holes, and then here is the depth minus stock offset times 2. This will be the counterbore diameter. This will be the depth minus stock offset times 2, but then we're also going to subtract the through hole thickness. And I didn't want to do that. We're not done just yet. What's the through hole diameter? And let's see, should be good. And let's just do a quick spot check. So our diameter is 0.781. Through hole diameter is 0.531. Let's hide our sketch. And then this surface to that surface is 0.19. So everything is how we want it, and that is our soft job link. Let me go back here real quick. So another thing I like to do is, because again we talked about those, the distance here to here is not the same, so there is technically a top. Just put a point up there, and we can just dimension it from this corner here, and just put it like 200 thousandths, and from there as well 200 thousandths. We turn it on, we have a sketch there. We can, I just use that like with a spotting drill, go in like 100 thou, just so I have a little dot. Saves me 30 seconds if I put it in, you know, wrong, upside down, whatnot. So here we have our solid model for our soft jaw. And the nice thing is, if you want to, for instance, let's say we have an 8-inch jaw. Now we should have 0.798 with our stock thickness, and just for sanity, we'll check the distance, 1622 and 1622. And I actually need to make tomorrow 2x2 soft jaws, so 2x2x6. So we'll say we'll keep the 2, and then we'll make the depth 2, and that should just increase this. And we've got our 2x2 with the correct stock. And then if we look at these two surfaces, we've still got that 0.19, which allows us to use the screws that came with the soft jaw vise, or with the Kurt vise rather. So just simple, you know, 5 minutes or however long that took to make these blanks, and then without having to redraw or create different models in one file, you just come in and change your parameters. You do that, it would update itself in the cam as well. So if I had some toolpaths in here, I would just regenerate when I change the parameters, and you're good to go. So I hope that was helpful. Just a real quick little demo, and just kind of highlight the power and the advantages of Fusion's parametric modeling. Hope you liked it. If I missed anything or did anything wrong or something I could improve, please let me know in the comments below. Always interested in improving my process. So thanks again for watching, and hope to hear from you.